So good evening everyone. Welcome all of you to this extra session discussion for this course. Computer Vision, and this course is taken by Professor Jayanta Mukhopadhyay, Professor Computer Science and Engineering Department, IIT Kharagpur. Myself, Ayan Paul. I'm a PMRF Research Scholar from IIT Kharagpur. I'm a PMRF TA for this course. My duties are I will solve few problems that will be similar to your assignment, so that whenever you will be solving assignment, you will not feel alienated. But as you all know, that we have completed with our 12-week discussion. This is an additional discussion or an extra session. So today I will be discussing the whole summary, whatever we have learned. First we will see what are the concepts that we have learned, and then we will just move around with few of the important questions, so that it will be very easier for you all. Okay, so let's start. So starting with topics on which week 1 assignment questions are based, that is regarding image. So that is very important concept, because this is a subject related to computer vision. So the most important thing over here is what is an image. Okay, so that is very important. And then geometric definitions of image, it is again very important. And then different concepts and operation for image processing, like image histogram is there. Then different gradient operations are there for this edge detection operation, like Sobel operator, pivot operator. So those are important, because those are important in terms of your numericals. Okay, so that is why this image processing concepts are important. And then there are I think different noise filtering operations also, like Gaussian noise filtering, median noise filtering. So those are also very important. And at last we have this image transform. So image transform mainly this Fourier transform concept is very important. Okay, so that is related to your week 1 topic. Okay, so this completes your week 1 topic. So what is important in conceptual point of view is image and the geometric definition of image. And numerical point of view, different image processing concepts and operation, like this image histogram is there. And then all this, like gradient image operation, which is very important for detecting the edge of the image, like your Sobel operator, pivot operator. Those are very important in case of this numerical questions point of view. Okay, and then different other concepts are also there, like noise filtering concepts are there, so that also you should know. And at last there is image transform. Again, image transform, there is something called Fourier transform, right? So Fourier transform is again very important, related to your numerical point of view. So numerical, and this is related to your theoretical point of view. This is important. Okay, so this is regarding the week 1 summary. Okay, and then let's move on to your week 2. Okay, okay, so week 2 point of view, week 2. Okay, so let me just 1 minute. Okay, yeah, regarding week 2, the topics which are important are, one is this real space and projective space. That is very important whenever you are talking about conceptual thing regarding this. What is a real space and what is projective space? Or projective space is also known as homogeneous space. Real space is also known as non-homogeneous space. So projective space means whenever we are talking about whenever we are talking about projective space, we are actually adding one more dimension to your real space. For example, if your point in real space is 2D, in a projective space that point is written like 3D. The third dimension is nothing but your scale. Okay, so that is very important. Like 3D is, if a real point is there, then in projective space it is written by 4 dimensions. The fourth one is nothing but the scale. Okay, so that is known as real space and projective space. So again, conceptually it is very important, as well as some short numericals, this is important. And then we have this points and line in projective space. Again, very simple concept. Just a cross product of 2 points will give you a line, and just the cross product of 2 lines will give you a point. Okay, in projective space. So again a very simple concept but important concept if we are talking about short numericals. Okay, and then intersection of parallel lines and lines and infinity, that is regarding your this affine concepts, etc. So that also you in theoretical as well as some few questions can be asked, but I think theoretical it does makes more sense. And then conics in homogeneous space, again you can just see over this topic. Projective transformation, that is very important. Okay, so projective transformation, we have this H matrix or the homogeneous matrix. So we can just project a point or even lines. Okay, project points or even lines from one space to another space. Okay, so that is known as projective transformation. So for that we have a matrix known as H. Okay, H is known as homogeneous matrix. So just multiply your point with H and you will get a point in your homogeneous space. So that is why this question, this is again a very easy concept, and this is both important with respect to your short numericals also. Projective transformation of lines as well as points. Okay, and then transformation of points line, yeah, under homography concept, that also you can see. And then at last measurement of angle under homography. So that also, this is actually a very short concept but very critical in terms of your numericals. Okay, so from this concept you can easily expect one numerical. Okay, so just see this concept, measurement of angle under homography. So that this is a concept under which you can get one numerical at least. So these are some of the concepts regarding your week 2 assignments. Okay, and then related to your week 3 assignment, week 1 we have discussed about image, week 2 we have discussed about this projection. Okay, homogeneous projection and projection, and week 3 we are just moving on to this camera geometry. Okay, camera geometry, then we have this simplest form of camera known as pinhole camera. Then there are other concepts like offset principle, point, shifting world coordinate. So there is something known as camera matrix. Okay, intrinsic camera matrix, and you can say intrinsic camera matrix and extrinsic camera matrix. So together that will form a projection matrix. Okay, projection matrix we denoted by P. Okay, so intrinsic parameter, camera parameter, and extrinsic camera parameter, if we both multiply it, we get something known as projective camera matrix. Okay, so that projective camera matrix is very important, and we have this different projective camera matrix. For a simple pinhole camera, it is one type, offset principal point. Okay. Offset principal point. Okay, someone I think was joining. Okay, no problem. Yeah. So so that was, I am telling that projective camera matrix, that is different for your pinhole camera, simple pinhole camera. Then offset principal point, we have a slight more complicated matrix than your pinhole camera matrix. And shifting the world coordinate, again we have a slight more complicated than your this offset principal point matrix, principal point camera matrix. So again you can just see it. And then CCD camera model, again it is more complex than your this shifting world coordinate projection matrix. And then projective camera matrix and all these properties, that is very important. Also in this you can get all your this fundamental matrix and all this. So please see this fundamental matrix, essential I think not fundamental matrix and essential matrix. I think I think we will learn more in this week 4. But this projective camera matrix and its properties. From this we can get all this properties related to your projective camera matrix, and then camera parameters from your projective camera matrix. What is the camera center? That is very important, so that we can get from your this projective camera matrix. And then projective camera on plane and line. If we just put a projective camera, how our plane and line will be projected. So that is very important in case of your numerical point of view. Okay, so numerical point of view, this is important. Projective camera matrix and its properties is important. Even this is also important. Okay, so all because from this also we have this different projective matrix. Okay, so different projective matrix, that is very important, so just go through it. And at last we have this camera at infinity, find projections, vanishing point and vanishing line. These are all related to your infinity. Okay, infinity concept. So again, these are I think more important, related to both your conceptual as well as numerical. So again, go through it, but most important in conceptual point of view is this from 2nd to 6th, I would say. So that is related to week 3rd discussion. Then week 4 discussion, we have this stereo geometry. Whenever we are talking about this camera geometry, then we are talking about only one camera. But to get the depth of the point or line, whatever that we are projecting, so to get the depth, we have to get 2 or more than 2 cameras. Okay, so that is known as stereo geometry. Okay, stereo geometry basically means 2 cameras, one is the left camera and one is the right camera, and both we are using to project a point so that we can get the depth of the point. So that is stereo geometry. So you can say week 4 is actually the complicated version of your week 3. Okay, so that is stereo geometry. So stereo geometry we have something called epipolar geometry. So each camera will have this epipolar points, and the total thing is known as epipolar geometry. So again, look into this, and then we have this 2 type of matrix. One is fundamental matrix and second is essential matrix. So this this essential matrix is the simplified form of your fundamental matrix. Okay, one is denoted by F, other is denoted by E. So again, look into this. This is very important in terms of your numerical point of view. Okay, so please check all this fundamental and essential matrix as well as properties of fundamental and essential matrix, where if a fundamental matrix is given, how you can get the epipoles, right epipole as well as left epipole, and also how to calculate the essential matrix. So that is again important in terms of your numerical point of view. And 5th, computing depth. This is a very simple formula for computing depth, that is ktx divided by x minus x dash, so that you can use. And this is again very important, related to your numerical point of view, and one numerical you can expect from computing depth. If your question is regarding your stereo geometry, then one numerical you can easily expect from your computing depth. Okay, so please don't left this concept. This is again very important. At last, estimation of fundamental matrix, that is more important, related to your theoretical, because to calculate fundamental matrix, it requires a lot of time. So definitely your numerical won't come from this estimation of fundamental matrix, but for concept wise you can just look into it. Okay, so these are the concepts related to your week 4 questions. Okay, and then week 5, moving to week 5. Week 5 is a continuation of your week 4 only, because here also we are discussing regarding stereo geometry only. So there is singularity constant of F and E. Again, conceptual problems will come. This is actually very important, parametric representation of F. Okay, so if you know the parametric representation of your F, you can directly solve many questions. Like you can directly solve all the question related to your parametric representation. So that is very important. So just go through this parametric representation of this F, and this is again very important, related to your numericals. And then retrieving camera matrix from F, again very important in case of your numerical point of view. So if you are given F, how you can retrieve all the camera matrix. So that is again very important. So this is important. Okay. And then we have this computing scene point. This is actually, it will again require a lot of time, so it won't come in your numerical point of view, but conceptually you can just go through it. Okay, And then we have this line reconstruction, plane induced homography. So plane induced homography, that is also introduced here also, so you can just look into it. And then affine stereo and stereo geometry summary, so all these things are there. But according to me, okay, okay. Oh, I think people are joining again and again, so I have to get a bit interrupt. Okay. So, yeah, so these are the things. So according to me, second and third concept are very important. So just look into it. The second and third concept, you can get many questions. And then moving on to the next part, that is topic on which week 6 assignment questions are based. One is this feature detection, then Harris operator, feature descriptor and feature matching, Harris Laplacian shift, and yeah. So first we are starting with feature detection. Okay. So week 5 only we have end with this stereogeometry concept. Now we are talking about feature detection, feature description, and feature mapping. So regarding feature detection, this one algorithm Harris operator is very important, and you can expect one question from Harris operator. Okay, because Harris operator, it is a very simple formula. I think lambda 1 into lambda 2 divided by lambda 1 plus lambda 2. So again a very simple thing. So if you are given a structured tensor, you can easily get your lambdas are nothing but your eigenvalues. So you can just get the eigenvalues and you can just calculate your Harris operator. So again a very simple concept but important for your numerical point of view. Then there are different this feature descriptor and feature matching algorithm. So Harris, Laplacian and shift are both related to your feature description and feature mapping. And we have this other three operator, that is fast, it is type of feature descriptor, brief for feature matching, ORB is a combination of fast and brief. ORB full form is oriented fast, and oriented fast and brief. Okay, rotated brief. So that is ORB. So that is also important. So this all I have given examples. Okay, I have given even numerical example. Not only the theory I have given, but what I have done in all my slides. First I have discussed the algorithm. I have also given the comparison, like what is the comparison between your Harris, Laplacian and shift. Then what is the comparison between these three, fast, brief and ORB. So you can just check, and also wherever required I have also given you the examples. Okay, so to clear your concept you can see the examples also. So question related to question, yeah, important, because numerical as well as theoretical question both can come with this with all this operator, Harris operator as well as this all this 5 operators. So again this is important. And then we have this reason descriptor, patch descriptor, texture descriptor and global image descriptor. This are more related to theoretical questions or conceptual questions, but numerical question you can expect from this Harris operator, and all this also you can see for this numerical question. So again this is week 6 is based on your 3 things, that is feature detection and then feature description and feature matching. So this is regarding your week 6. Then week 7 was related to your this is actually a bit of continuation of your feature matching only. Feature matching what we have learned in the week 6, but here there are other concept also. So first is all this key point distance and similarity function, very important for numerical point of view. Again a very simple concept. Okay, just go through the slides, very simple concept, and these are very important for your numerical point of view. And then matching criteria, again distance based and matching histogram, again very important concept related to your numerical point of view. Okay, so very easy concept but very important related to your numerical point of view. So please go through it. And then efficient computation of feature matching, range query indexing, and your KD3 indexing, that is your KD, and the hashing that is known as local sensitive hashing. Okay, or LSH. So again the concept that you can see. So these are I think more related to your conceptual. Yeah, you can get how to form a tree in this KD tree, and also you can see some of the question related to LSH, but these are more related to your conceptual. Okay, and then this part that is very important. This is ultimately a different topic on its own, that is straight line model fitting, least square, total least square, ransack and hover voting. Every thing has some formulas and some numerical. Okay, so most important numerical that you can expect always is regarding this least square and the total least square. So just remember the formula of least square and total least square, and you can solve all the problems related to it. Very important. So please see it. And then we have this, someone is joining, yeah. Then we have this ransack, that is random sampling and consensus, and then how voting. These are again how voting and random sampling and conceptual, very simple numerical, but just see the concept. I have always given all the examples related to everything, so just you can just see the slides that I have given you. I have discussed the theory, as well as I have, wherever necessary, I have given all the examples, okay, related to the concept, so you can easily get all the concept as well as numerical. And then related to week 8 we have moved from this feature matching to colors. Okay, so colors, what are the definition of color and color perception? This is related to your conceptual part. Numerical, there are not many numerical. And then trichomacy, linear color spacing, color matching, again conceptually this is good, but this is very important. What are the different color models? Okay, so from this you can easily expect some numerical at least. Okay, like RGB model, CMY, CIE XYZ, CI chromaticity, and the CI lab, YIQ, YCBCR, and then HSV. So from this you can easily expect a numerical problem. Okay, so this is again very important. And color constancy and color transfer. So color constancy also you can see, again this is a simple concept, but from this you can get one numerical from color constancy. And color transfer more related to your conceptual. I don't think numerical won't be asked from this, but it is more related to your conceptual. Okay, and at last color demosaicing and interpolation, that is very important. That is related to your CFA, that is color filter array. Okay, so color filter array, we have this three concept: bilinear interpolation, then average red blue hues, and at last Laplacian color corrected edge correlation. Okay, LCEC. So most important thing and most, I think, confusing thing is this part. Okay, average red blue hues interpolation. So you just please focus on this, and this total thing is also very important and related to your numerical point of view. So please look into this, and from this also you just see this average red blue hue. Okay, because bilinear interpolation you can do, but average red blue hue, this is actually a confusing thing. Okay, so please go through this. So this is regarding your week 8. Then week 9 from colors we have moved to your stereo imaging, range imaging. Okay, so range imaging, what is the difference between your color image and range image? Color image means XY coordinate will give you your pixel values, that is color image. But range image means XY coordinate will give you your depth value. Okay, so that is known as range image. Okay, so that is why range image is also known as 2.5D image. Okay, 2D image means your simple color image, but 2.5D image means your range image, because X and Y here will give you your not your color values, but this pixel will give you your depth values. Okay, so that is range image. So range image, someone is joining, yeah. So that is related to your range image, and there are different type of range sensors, like different type of range imaging techniques, you can say: stereo imaging, time of flight, triangulation through scanning beams, and structural light. All these are very conceptual questions, so conceptual question you can expect from this, but there are no numerical question related to this. Okay, and then this part is very important, that is differential geometry and extracting the local feature of a pixel point in a range image. That is very important, like to get the surface normal, principal curvature, Gaussian curvature, and mean curvature. Everything has some formula, so please go through this concept. This is very important related to your numerical point of view. Okay, so please go through this concept. I just request you, please go through this concept. Okay, differential geometry, local feature of picture point, everything. So please go through it. I have given you both the formulas as well as the whole definitions as well as concept related to it. Okay, so please look into the slide that I have provided you, and you will get all this, and this portion is very much important with your numerical aspects. Okay, and then characterization of step and roof edges, again both conceptually and numerical point of view. This is very important, both conceptually and numerical point of view. Okay, again I have given you both definitions as well as examples, also example question also, so please go through it. Characterization of step and roof edges. So here edge is like color image. The edge you calculate the edge by nothing but your differential operation, but here you calculate the edges with your this here you calculate, there are different type of edges, step and roof edges, because here we are talking about not the color images but your range images. So here we have different type of edges, step edge and roof edge. So this is very important, both related to your conceptual as well as numerical point of view. And then there is this segmentation, range images into planar patches. This is important with respect to only conceptual point of view. Here you can get two concepts, one is NPS and another one is DNP. Okay, so please go through it, what is NPS and what is DNP. You can get a more clear view regarding this segmenting range images into planar patches. And at last you have this registration of the range images, so that also is important with your conceptual point of view. So numerical point of view, these two are important. One is this characterization of step and roof images, and most important is this. Okay, second thing, that is all this thing like surface normal, principal curvature. This someone is joining. Yeah, surface normal, principal curvature, Gaussian image, and Gaussian curvature and mean curvature. So these four are very important, and out of this four also, this two are most important. One is Gaussian curvature and mean curvature. From this you can at least expect one numerical. Okay, so this is regarding your week 9, that is range image. And then week 10 we have discussed regarding your types of learning, like supervised learning, unsupervised learning, and reinforcement learning. Supervised learning, we have talked about this classification. Okay, unsupervised learning, we have talked about this clustering. Okay, unsupervised learning, if I start with unsupervised learning, that is clustering, we have this three algorithm that has been discussed: k means, k midoid, and Gaussian mixture model. Okay, k means, and out of this k means and k midoid are very important related to your numerical point of view. Okay, k means and k midoid. Gaussian mixture model, you just read it more for your concept. Okay, numericals, there are not more numericals related to it, and numericals are also very long numerical related to Gaussian mixture model, though I have given numericals in your example in your Gaussian mixture model, but that you won't expect in your exam, because these questions are very long. Okay, so that is why you can't expect more from your Gaussian mixture model, numerical question from your Gaussian mixture model, but more a conceptual question. And then classification, we have this Bayesian classifier. This is very important, actually very much important in case of your numerical point of view. In your whole exam you can at least expect one question related to Bayesian classification or Bayes theorem. Okay, so please go through what is a Bayes theorem, it is very important. And then k nearest neighbor, again very important with respect to numerical. LDA also you can see, but LDA also you can see with respect to numerical point of view. Perceptron classifier, again numerical point of view you can see. Artificial neural network, though I have discussed the artificial neural network in detail and also given a long question of it, but long question you can't expect, but the short form of it, like you have been given a neuron and you have been given inputs and weights, and you have to calculate the output. Such type of question you can expect. Back propagation and all this are only in theory in your this course, but back propagation you won't expect from your in your numerical question, because that takes much amount of time, so that won't come. But simple artificial neural network question, like given an input and weights, just calculate the output, such type of question. So this is related to artificial neural network. And then evaluation of classifier, again important for your numerical point of view. For example, if you are given a confusion matrix, just calculate all those parameters like precision, recall, F1 score, etc. So again I have discussed in detail. You can just check what is a confusion matrix and what are all those evaluation parameters of a classifier. And at last, cross validation. Cross validation, this is totally related to your conceptual point of view. So as we are splitting training and testing data, if we take different type of training and testing data, definitely our result would be different. So that is why how we can create our testing and training data so that we can get a better result. So that is cross validation. So again I have discussed in detail and also given a good type of content related to cross validation, so you can just see in my slide. And then week 11 we are moving from this different types of learning to this dimensionality reduction. Okay, so dimensionality reduction, you have PCA, that is principal component analysis, but also we have this Fisher LDA. Okay, so these two are very important related to your numerical point of view, both the principal component analysis and Fisher LDA. Okay, so please go through it. Principal component analysis, it is basically related to nothing but your eigen vector and your eigenvalue calculation only, so that you can just see. And Fisher linear discriminant analysis, you have this scatter in between classes and scatter within classes. These two matrices are very important, so again you can expect a numerical from this. And this sparse representation, there can be a short numerical related to this, but more important in terms of conceptual point of view. Then pursuit algorithm. Okay, someone is joining. Then pursuit algorithm, we have this three types of pursuit algorithm: matching pursuit, orthogonal matching pursuit, and basis pursuit. Okay, so out of this is very important in terms of this numerical point of view, that is orthogonal matching pursuit. Okay, so pursuit algorithm, it is nothing but to have a good approximation of your sparse representation. Okay, so out of this orthogonal matching pursuit, this is important in terms of your numerical point of view, so please go through it. And others also you just see, but in case of this numerical point of view, you just go through this in detail. And at last, dictionary learning and sparse representation, this is conceptual point of view, this is important. Okay, so numerical point of view, just go through this principal component analysis and this Fisher linear analysis in detail. Okay, and then sparse representation, just conceptual. Okay, and then pursuit algorithm, this orthogonal matching pursuit is very important in terms of your numerical point of view. And at last, dictionary learning and this KSVD, again it is important for your conceptual point of view. Okay, so this is regarding your week 11. And at last we have this week 12. Week 12 is related to your CNN and RNN. Okay, so CNN, this is a vast topic. Okay, CNN, this is a vast topic, and you can easily expect some question like first you have to, both conceptually and numerically it is important. Okay, both conceptually as well as numerically like what are the different output dimension. If you are given an input dimension and then convolution filter dimensions are given, then you just have to calculate what are the output dimensions. So that question is very important, so please go through that. And then other question, yeah, this is actually most important question. And also the number of parameter, like if you are given a convolution filter, then how many parameters that you can expect from the output, as well as if you are giving a pooling layer, how many parameters you can expect. So if you are given a pooling layer, parameter will be 0. Okay, but convolution layer, there is a formula, and there similarly there is a formula to get the output dimension from both your convolution layer as well as this pooling layer. Okay, so that is why this is very important related to both your conceptual as well as numerical point of view. Convolution neural network in detail. Then CNN architecture, this is just conceptual. Okay, so you can just go through it. There are different CNN architecture basically for image classification. These are all for image classification. So you have this LayNet, AlexNet, ZFNet, VGG, GoogleNet, and ResNet. So this GoogleNet and ResNet, they have a slight better concept. Like GoogleNet, you have this inception module. ResNet, you have this ResNet feature. What ResNet do is uh, it is not a simple feed forward network. For example, it take value from your previous inputs also. So ResNet is very important. So just go through the concept. It is important regarding your conceptual point of view, not any numerical. Then CNN for detection, again important for conceptual point of view, but you can only expect one numerical, that is relating to your inference time. Okay, to calculate the inference time. So to calculate the inference time, there are two different formula for this and this. Faster RCN, fast RCN, and you have different formula for this and different formula for this. Okay, to calculate the inference time. So again, that concept is important in case of numerical point of view. CNN for segmentation, again conceptual. RNN for I don't think you have much question related to for your numerical, but conceptual point of view, again you should know what is RNN. So that is regarding the whole 12 weeks. So again, let me just brief it. Week 1, it is related to image and definitions. Week 2, it is related to your projective transformation or the homogeneous transformation. Okay, so that is week 2. Week 3, it is related to your camera geometry or the projection camera metric. Okay, so that is more important. Week 4, is more related to your stereo geometry. That means not one camera but two camera. Okay, to get the depth. Okay, that is week 4. Week 5 is the continuation of week 4 only. A slight ahead concept of week 4. Okay, so you can just see in week 5. Then week 6, you have this three techniques called feature detection, feature descriptor, and feature matching. Okay, that is related to week 6. Week 7, you have this. Week 7 is again a bit of continuation of your week 6, but it is more related to your different matching criteria and more formulas are there. So that is week 7, and also this part is new, that is line fitting, straight line fitting. Okay, so that is least square and total least square, ransack and hoverting. So this is important. So that is week 7. Week 8, is related to color. Okay, colors and different color model and all the CFA terms. And then week 9, is related to your range image. Week 10, is related to your different types of learning, basically clustering and classification. Different type of learning mean unsupervised and supervised learning and reinforcement learning. Out of this unsupervised learning, clustering is a type of unsupervised learning and classification is a type of supervised learning. Okay, so all this clustering and classification and different type of algorithm related to clustering and classification. So that is week 10. Week 11 is related to your dimensionality reduction, PC and Fisher LDA, that is important. And week 12, that is related to your CNN and RNN, that is convolution neural network and your recurrent neural network. So that is week 12. So that is the whole summary that we have learned, okay, from week 1 to week 12. Any doubt or anything you want to ask me regarding from week 1 to week 12? Any concepts that you find difficult or anything that you want to ask? Okay, so my slide was not visible up to now. Was my
Yes,
slide?
sir. Now only visible.
Oh, you should have told me, na. So that was I was discussion. So again, let me show
We are
you.
not aware that you are using slides, sir. You are presenting.
Okay, so you should have
But
told.
we are noting your.
Okay. So again, let me show you. So sorry for that. I was not aware that my slide was not visible. I don't know
Okay.
how it got unshared. Okay, so let me again uh, just discuss it. Okay, so week one, we are discussing more about this image. Okay, image definition. So these are the different concept, and from this, which are important is image and geometric definition. You can get the otherwise you get confused. This theoretical question you can expect more from this image and geometrical definition of image, and this image processing concept like this pre-weight Sobel operator, etc. You can get numerical question as well as image processing like histogram equalization, and then different different this gradient operation like your Privet-Sowell operators, so that you can expect from your for your numerical. And then image transform that Fourier transform, you can get numericals related to your Fourier transform. And then these are the week 2 is based on your homogeneous projection. Okay, homogeneous projection or your projection difference between your real space and the projective space, so that you can get conceptual as well as numerical problem, points and line in projective space. Numerical problem, you can get intersection of parallel lines and infinity, that is that you can yeah, this too you can just see, and more conceptual related question you can expect. Projective transformation, very important, so you can easily expect a numerical question, like if you are given a point or a line and you are given a H matrix, that is homogeneous matrix. Okay, how you can get the points and line in the next homogeneous space or the different homogeneous space. Okay, so that is very important. So projective transformation, so of a point, line as well as convex, so that you should know, so that this too you can expect a numerical question more. And at last, measurement of angle under homography, you can get a you can expect a numerical question. Again, this concept is very important related to numerical point of view. Okay, very simple formula is there for measurement of angle and the homography. So just learn this, and this concept is again very much important related to your numerical point of view. Okay, so please go through this concept, that is measurement of angle and the homography. And then week 3 that is more related to your camera geometry. Okay, camera geometry, camera geometry, you have this different type of cameras. So camera geometry, this is conceptual, and then different type of cameras. Every camera you can get a different camera projection matrix, or P. Okay, P matrix. So dimension of H matrix is 3 cross 3. Okay, but dimension of P matrix is 3 cross 4. Okay, so for each of this pinhole camera and offset principal point, shifting coordinate as well as CCD model, you will get different P value, that is camera projection matrix. So both these things are very important related to your numerical point of view. And once you have P, to get different camera properties from your projective camera matrix. Okay, like what is the camera center, etc. Again, very important related to your numerical point of view. And then camera parameters from this projective camera matrix that I have told you. Then projective camera of line and plane, again numerical point of view. If you are given a plane or line in front of the camera, then how it is projected. So again you can get numericals related to this concept. And camera at infinity, affine projection, vanishing point and vanishing line. Again, this is important related to both your conceptual as well as numerical point of view. So just see the formulas of all this and you can get some question related to it. Okay, but most important over here is this part, that is 4th and 5th. Okay, that is projective camera matrix and its properties, and this camera parameters from your projective camera matrix, and also projective camera on a line and plane. Okay, so 4, 5, 6 and some part of 7, that is most important. And then week 4 is related to your stereo geometry. Okay, stereo geometry, camera geometry means only one camera, stereo geometry means two cameras. Okay, two cameras to get the depth. Okay, so that is why this portion is most important related to numerical point of view. You have this very simple formula, ktx by x minus x dash. From that you can compute the depth. Okay, so that is why this the serial number 5, that is computing depth, this is most important related to your numerical point of view. One numerical you can easily expect from your computing depth. And then stereo geometry, epipolar geometry, conceptually these are good. Then fundamental and essential matrix, this is also important related to your numerical point of view. Fundamental matrix denoted by F, essential matrix denoted by E. Okay, and then properties of fundamental and essential matrix. If you are given a fundamental matrix, you can also be asked to get the camera matrix. Okay, like f e dash equals to 0 or f dash t e or transpose of f dash into e. That also you can get a different epipole. Okay, just go through it. So if you are given a fundamental matrix, how to get the camera geometries. Okay, that is also important. So these two are also important related to your numerical point of view. And at last, estimation of fundamental matrix. This is important related to your conceptual point of view, because it is very long concept. So long calculation. So definitely it won't become in your exam, because it is long to calculate the total fundamental matrix. But conceptually you can see how to calculate that. And then week 5 is a continuation of week 4 only. You have different concept, but most important is parametric representation of f. That is very important. Okay, so if you are given a parametric representation, how to get the epipoles, that is important. So that is why second is very important related to your numerical. And third, that is retrieving camera matrix from f. That is again important related to your numerical point of view. And then computing scene points, line reconstruction, all this theories you can see. But second and third are the most important related to your numerical point of view. And then week 6 you have these three things like feature detection, feature description, and feature matching. Feature detection, you have this Harris operator. From that, it's a very simple operator. Okay, like I think lambda 1 into lambda 2 by lambda 1 plus lambda 2. So again it is very easy to calculate the Harris operator. Lambda is nothing but your eigenvalues only of a structure tensor matrix. Okay, so again it is very easy formula, but again one numerical you can expect from your Harris operator, because it is only algorithm for your feature detection. And then feature descriptor and feature matching, you have this Harris, Laplacian, and Shift. Okay, again you can check. And then fast, brief, and ORB. Fast is a type of feature descriptor, brief is a type of feature matching, and ORB, that is oriented fast and rotated brief. Okay, so that is the combination of your feature description and a feature matching. So this two also I have given all the numericals in the example. Okay, for each algorithm I have given the numericals wherever it was necessary. So please go through my slides. Also I have differentiated like what is like if I have given Harris, Laplacian, and Shift at once, so I have also give you a difference table. Okay, what is Harris, Laplacian, and what is Shift. Okay, so please go through it. Similarly, fast, brief, and ORB also I have given a difference table, so please go through it. Okay, so from this to also this 5 algorithm, that is Harris, Laplacian, Shift, and all this, you can expect both numerical as well as this conceptual problems. And at last, region descriptor, from this you can expect only theoretical question. Patch descriptor, texture descriptor, and this global image descriptor. So from this only theoretical description. And topic on week 7 is based topic week 7 is based. So week 7 is a continuation, bit of continuation of week 6, because it continues this feature matching only. So feature matching, there are certain you can say numericals related to feature matching, like key point matching. You have this different distance and similarity function, so very important in terms of this numerical point of view. Okay, just see it, distance and similarity function, very easy formulas. Also I have given all the example questions also related to each distance. Just 1 minute. Okay, and then and then this matching criteria also, distance based matching and matching distance based matching and matching histograms is there. Again numerical questions are important related to this, so please go through this two concept, please go through this to get the numerical questions. And then efficient computation, feature mapping, this is more actually related to a conceptual point of view, but again KD and LSH, you can just see one numerical of each. Like indexing, we have this KD tree, so how to form the tree, etc. So a smallest conceptual question might come, so that is why you just go through it. And then straight line and this model fitting. From this is the most important part of this week 7, that is straight line model fitting, that is least square and total least square. From this least square and total least square you can easily expect one problem. Okay, from this two you can easily expect one numerical problem. So please go through it, what is least square and what is total least square, and how to solve a question related to this. Then ransack, that is random sampling and consensus, random sampling and consensus. Okay, so again that is very important. You can get a small numerical question related to this two, that is ransack and this how voting. Okay, so very small numerical you can expect, but this is very important, that is least square and total least square. You can get a good numerical question from this, so go through it. And then week 8 is related to color definition, that is colors. So colors, the most important, that is most important concept for this numerical point of view is different color models. Okay, different color models and all the formulas associated with it, like RGB, CMY, CIEXYZ, CILAB, and all this HSB. And then color demosaicing and interpolation, that is CFA filters, that is color filter array. So from this we have this two thing, bilinear and average red blue hues, and you have this third thing, that is LCEC, that is Laplacian corrected edge correlation. From this this is very total, this is very important related to your numerical point of view, but out of this also bilinear is easy, but this is the most important part, that is averaging red blue hues. Okay, that is very confusing actually. So that is why I would say that please go through this concept, that is averaging red blue hue. Okay, that is most important. Laplacian is easy, but again please go through it. You can expect one, definitely one numerical you can expect from this whole thing, that is CFA. And then color constancy, you have some formula for color constancy. So again, a numerical point of view, you can see color transform, it is for conceptual point of view only. And this too also conceptual point of view. So numerical, if I talk about numerical, this color model and this color interpolation and demosaicing. Okay, so just see this concept, third and sixth in for this numerical questions. And then week number 9, it is related to
Oh no.
okay, yeah. So week 9 is based on this range image. Okay, range image is nothing but your 2.5D image. If you talk about this color image, so that is 2D image, because each x and y will represent the each xy, that is pixel value, will represent nothing but the color values. Okay, color values, or color values. But when you talk about a range image, each xy will represent nothing but your depth. Okay, that is why it is also known as 2.5D image, range image. So from range image, what is important in terms of this numerical point of view is this. Okay, that is differential geometry in extracting feature of a pixel point. Okay, that is surface normal, principal curvature, Gaussian curvature, and the mean curvature. Out of this Gaussian curvature and mean curvature, this is very important in terms of your numerical point of view. So please go through this whole concept for numerical, and from this also this too is very important, it is Gaussian curvature and mean curvature. So please go through this. And then this different type of edges are there, one is step edges and another one is roof edges. These two are very important for both conceptual as well as this numerical point of view. So go through it, how to calculate the step and roof edges, as well as this as well as what are the concept related to it. So this is also important. And this fourth, that is segmenting range image into planar patches, this is important in terms of this conceptual point of view. And registration, this is again conceptual point of view. But in this segmenting range image into planar patches, you have this two concept, like DNP and your NPS. Okay, so please go through this two concept, DNP and NPS. This is actually very important in your conceptual question point of view. So this is regarding fourth. But numerical second, third is very important. Okay, second and third. So that is related to your range image. Then week 10 is related to your different type of learning. And different type of learning, you have this unsupervised and supervised learning. In unsupervised learning, they have discussed regarding clustering. Supervised learning, they have discussed regarding classification. Clustering, you have this different algorithms, k-means, k-medod, and Gaussian mixture model. K-means, k-means and k-medod, these are very important related to your numerical point of view. Gaussian mixture model, though I have given a question related to your Gaussian mixture model, but you might have seen it is very long question. So that is why Gaussian mixture model, you won't expect the numericals, but conceptually you can just visit. And then classification, you have this Bayesian classifier, k nearest neighbor classifier, and all this classifier. From this, the most important is this Bayesian classifier. Okay, so just go through it. One question in your whole exam you can easily expect from your Bayesian classifier or the Bayes theorem. Okay, so please go through it. And then LDA here is not very important, but the week 11 it is important related to your dimensionality reduction. So there it is more important. Then here perceptron classifier, that is important related to your numerical. And artificial neural network. Artificial neural network, simple question, not complex question like they won't ask back propagation and all, because it will take more time, so that they won't ask. But definitely, like given two inputs and just given two weights, just calculate the output. This type of simple question you can expect from your artificial neural network. Then evaluation of classifier, this is again very important related to your numerical point of view. Classification of evaluation of classifier means confusion matrix. Okay, they might give you a confusion matrix and ask different values like precision, recall, and other matrix. Just go through those slides and you can easily get one question from that. Okay, so that is very important related to your numerical point of view. And cross validation, conceptual point of view it is important, but again there is no numerical related to your cross validation. And then week 11 is related to your dimensionality reduction. Okay, so that is PCA and your Fisher LDA. Okay, so principal component analysis is very important related to a numerical point of view. Principal component analysis is nothing but to calculate your eigenvalue and eigenvector. Okay, so that is very important. And then Fisher's LDA, that this scatter within the classes and scatter between the classes. These two are very important related to your Fisher's LDA. Okay, so please go through the concept. These two together very important for your numerical point of view. Okay, this both Fisher principal component analysis and Fisher's LDA. Sparse representation conceptually is good, and small numerically you can expect, but conceptually it is more suitable. And pursuit algorithm, there are three pursuit algorithm, but out of this numerical you can expect more for this orthogonal matching pursuit. Okay, then this dictionary learning and sparse representation, only conceptual question you can expect. And then week 12 CNN, that is very important for both conceptual as well as your numerical. Okay, like what is the dimension, or what is the output dimension when a filter was there or when a pooling layer was there. Filter means convolution filter was there, or when a pooling layer was there. Also, what are the number of parameters when a convolution filter is there, or when a pooling layer was there. So that this question is very important related to your numerical point of view regarding this conventional neural network. And then this all CNN architecture, CNN for detection, CNN for segmentation, all are important for conceptual point of view. Numerical you won't expect, but in this CNN for detection there are numerical related to your inference time. Okay, so inference time for RCNN or faster RCNN, and faster RCNN. This two, fast RCNN and faster RCNN, you have same formula. RCNN you have different formula. Okay, so just go through it to calculate how to calculate the inference time. Okay, so that is important. RNN also there are no numerical, but again conceptually it is very important. Okay, regarding this RNN. So this is the whole theory from your week 1 to week 12. Okay, so anything you want to discuss regarding your week 1 to week 12? Any portion that you found difficult, or anything you want to ask, what can come in exam or anything?
Thank you, sir.
Okay.
Sir, in the final examinations, which type of questions will be common?
I have told you, right? Week 1 to week
Yeah,
12 I have
it
to.
good, but concept
Sir,
wise,
main thing is many topic are there, sir.
Can you please repeat? I just can't hear you.
Many topics are there.
Yeah,
More.
many topics are there, but like 12 weeks are also there, right? So you got sufficient time, I think, to get all the topics.
different based problems will come or different problems will come, sir.
Different problems will come. Why same
Different.
why same problem will come?
Uh,
Different. This is an exam, right? So exam means different problem will come based on the same concepts. Okay,
okay.
same concept that you have learned, different problems will be different, definitely different, because this is an exam. Okay.
Yeah, yeah, we know that this is exam. But if you don't mind, can you please send us a list of problems,
List of problem will be very similar like assignments only. If
assignments only?
yeah, if your concepts are, Dhatri, just let me answer him first and then I will answer you. So yeah, so if first go through all the concepts, that is very important. Each and every topic just I have discussed, go through all the concepts first. Then the numericals I have told you, the numericals which are important, just memorize the formula of all those concepts. Okay, this is two first. Then go through all your assignment question. You will have 12 into 10 assignment question, 10 assignment question for each week, right? So 12 into 10, that is 120 question. After, if you have time remaining after 120 question, then go through question of TAs. Okay, not every question, definitely not every question, but that question you feel in your assignment, that question you feel a little bit tricky or dicey, or you feel you need more practice regarding that you can see all the TA question. You have 3 TAs, right? So 3 TAs you can have same question or different question. Some question might be same only, but some question may be different also. So that you can do. If you are done with this, definitely you will score good. Okay, no need to worry
Okay.
about anything. Okay.
Both theoretical and problematic as well will come,
More
right?
numerical you can expect. Okay.
Okay.
Conceptual, yeah, there are some, definitely some conceptual problems are there, just like your
Okay.
every assignment you can check. Okay, more questions are numerical, right? You can easily
Yes.
get 6 7 numerical question, okay, and then 2 3 question you have left with conceptual. That
Yeah.
is general. Okay, but then again there are different weeks, like the range image week, there you can get a more conceptual question like that. Okay, so there are mixture, but more you can expect numerical question than your conceptual question. Okay, so that is the
Okay.
whole thing. If you are done with this, definitely you will score well. No need to think like there are so many things and so many things are there. Just go through 120 question. At least you can go through this 120 question, right? Because that only you have solved. Just clear those 120 question. Just clear your concept as well as the important numerical formulas, okay, that are important for solving those assignment question. If you are done with this, definitely you need not to fear anything. Okay, that is my only suggestion. And if you have time remaining after this, just solve all our question, all the TA that has been the question that has been given by all the TA, just solve all this. Okay, so that is how you should plan your this plan how to prepare for exam. Okay, so that is this. Yeah, Dhatri, you had asked something. Can you please send some sample papers for our reference? I don't have any sample paper, sorry, that I cannot send, but definitely just if you just go through your assignments only, the question will be very much similar to that only. Okay, no need to get fear of anything. Okay, so this is my only suggestion. The another tip that I want to give you is, from now on, okay, from after this, please do all your calculation by virtual calculator, not your this scientific calculator. Okay, virtual calculator, just let me show you. Yeah, virtual calculator, you can just open Google. Okay, open Google and just, yeah, open Google
Sir,
and
your
just,
slide not visible.
yeah, I'm just,
Yes, now.
yeah, so just open Google and just you can just write gate calculator, okay, because virtual calculator will be similar to gate calculator, okay, and you can get different links. Just open this. This is the scientific calculator in virtual form, okay. This is important. Now you will say, sir, same thing, like same thing like scientific calculator, and what does it matter? But definitely it matters, okay, because if you will calculate on this, then only your flow will be good. And again there are different type of like what I will say, yeah, here everything you have to do in a BODMAS way. For example, any two different calculation you have to do, you have to put everything in bracket and then do. And also regarding use of operator, like whenever you are using uh, like uh, whenever we want to get any operational value like tan, like sin something, okay. So what you do in your normal scientific calculator, you just do the sine operator and then you put the degree or anything, degree or radian, whatever. But here just see, sine and 0 is coming, okay, and you can't put the value, okay. So this is how it is different, okay. So here what you have to do, like I want to get sine 30, so first I have to put the value and then I have to put the operator, then only I can get the answer. So that is why it is different, okay. So please from now on, please please prepare all your calculation in this virtual calculator, okay. There are different things also whenever you want to calculate two different type of values, like you have to use this bracket, like 4 plus something, okay, and then you have to do some multiplication like this. So you have to do 4 into 10, okay, 4 into 7 or 4 into 7, whatever. So like this, okay. So this is the answer. Then again you have to press this equals to, then only you will get answer, okay. So please from now on, whatever calculation you want to do, just do with your scientific calculator. So this is again one of the important tip that I want to give you.
Sir, please land operation, sir.
Uh-huh.
Natural. Land logarithm.
Acha, log operation, okay. Log operation again same thing, like log there are different operation, like again there are two things, like I think, yeah, x and y. So first you have to do the, I think x, just let me see, 5 log x base y. So 5 no, I think even I forget how to do it, but yeah, like log 2 is easy, like for doing log 2, just put this and then put the operator. So this is
Yes,
log,
simple logarithm is easy, sir.
uh, and here I think first you have to
Before seven,
x
before seven, it's available. Log.
before
Before 7, that point. Log operation, sir.
Then,
7.
Before the number 7. Yes,
uh,
yes, yes.
yeah, yeah.
Before.
Before 7 it is very easy. Just do this. Okay, before 7 that is easy. But what my doubt is this, like log something base something. Okay, so
Base.
for that first you have to definitely put this, but then I am putting this, so base y is coming. So is the base 8 I have to put? Yeah. So you have to do like this. Okay. So again I repeat, x and y is there, right? So first you have to do the x. Okay. So like 5 log, yeah, and the base you have to set, then again you have to do 8 and then you have to do this, okay. So that is log base. This is simple. This ln and log is simple. That is very, log means log base 10, okay. Don't confuse log base e, that is natural log is ln, okay. So please don't confuse. This is very easy. Just put the first put the value and then this ln operator, okay. That is natural log operator, and this is log base 10, okay. Like if I do this 10 log base 10, that will give me 1, okay. So this is very easy, but this is again easy, but this is kind of kind of, just you have to understand it. Just first you have to put the value, then you have to put the operator, and then you have to put the base, okay. So these are some of the tricks of this scientific calculator in the virtual mode. So please from now on, please practice all your uh, calculation in this form, okay. So this is one of the tip that I want to give you. And yeah, for and then I think can you yeah I think after this I have put some of the question, but those question are same
Sir, I
as
have another doubt.
yeah please.
Some problems during the solving, the steps are more problem.
Steps are more okay.
It's enough time is available, sir, because only 3 hours is there.
So they will prepare the questions accordingly, right? So
Uh,
yeah, they
so
will.
during the assignment solving time, we
Yeah,
have more time to solve the problems.
yeah.
But during the exam only, we have the 3 hours.
Actually, the pattern, even the pattern, total pattern, I don't know. So you can just from in that uh, wherever you get all these weeks and etc. There is some discussion form, right? So in discussion form only they will give all the things, like when will be your exam date and everything, exam pattern and everything they will give you, and also you can check the internet also, so that from that also you can get what is the exam pattern and etc. uh, Accordingly also you can practice, okay. So this is
Okay.
how
Sir,
you can
also
practice.
shall we go through your problem solving session problems? Because every time you solve some exercise problems and some
Yeah,
questions, 10 questions.
yeah, so
Is
that
it necessary to check?
yeah, yeah, so that was I that what I told you na. First, whatever I have whatever concepts we have discussed, just go through all the concept. After that,
Oh,
from that concept, whatever the numerical formulas are important, you go through all the numerical formulas and memorize all those numerical formulas, okay. So that this is the second step. Third step, go through all the assignment problems, okay. 10 assignment problem and 12 week, that means 120 problems.
120.
uh, so first these are the first three steps. After that, if you have time, so you go through our assignment. We have 3 TAs. So 3 TAs, I don't know, we discuss the same problem or different problem, but most of our problem will be similar only. In that also, you please go through the question that you got dicey, or that you found difficult, or that you found time consuming in solving in your assignment question. That only you focus in whatever we were teaching, okay. Got
Okay,
it?
okay. Thank you,
Got
sir.
it? These are the four steps, four, 5 steps. So if
Thank you.
you will do it, I think it is enough. And from now on, please practice all your calculation in the virtual calculator, okay? Not any scientific calculator, because that would be not allowed, and it is that different, because this is my personal experience, okay? Because in gate exam also, I have given the gate exam in 2020. So in gate exam also, I have seen some of the fellows that who are brilliant, okay. So they just in the exam they just found it very difficult in doing the calculation in the virtual calculator, okay. So that is a tip that I would give you. So please, all your from now on, all your calculation in your virtual calculator. So that is the tip. And then any other doubts?
Sir, in the final examination, maybe I think 50 questions will come, sir.
50 questions will come.
Yeah, on
Okay,
21st September, I wrote a database management exam.
okay.
Oh, in that exam, it has three parts, sir.
Okay,
Part one, part three.
okay,
So, part one has only five. It contains 5 questions.
okay,
Part two, 7 questions, and part three, 35 questions. Total 50 questions.
okay. So what
So,
type of
more
question in all the three section A,
three.
section?
That is database management system, sir.
Yeah. But still means section A, what type of question? Section B, what type of question? And section C.
Same, same questions. I mean, different questions, but the questions came from different topics. All
Okay.
are based on queries, SQL queries.
Okay. No, my question is like 5 question section A, that will be like small question. Section B would be medium question, and section C
No,
will be
all
like that, or
basic
something.
query. We have to identify queries
Okay, so
based on
that is
type.
related to subject. Okay, so yeah,
Yeah,
I will try if I get sample question related to this subject. I will put on in that folder only. Okay, so I will try.
most in part two, 7 questions are there.
Okay,
Seven out of seven, 5 questions will came from last week assignment questions.
okay,
Yeah.
nice.
So maybe I think in this exam also same. I think I am expecting like that.
Okay, okay. So definitely I will then search some of the sample paper. If I get some sample paper, definitely I will share. And if I don't
Yeah.
get, please
Correct.
you all also try on your own to get some sample paper from the internet. If you get, it is okay. If you don't get, just do all that I have told you. If you do all this that I have told you, I think you will be good to go in your
Yeah,
exam.
result also came. I got elite certificate.
Okay, okay. Congratulations for that.
I,
Okay. So after this, I have just kept few of the questions, but definitely we won't get time to solve all the questions. But at least just go through. Let's get through the concept. So this is regarding the histogram equalization. Okay, histogram equalization. So again, it is very simple. You just focus what is frequency, cumulative sum, and normalized sum. Okay, frequency and cumulative sum. From this two, you can get the normalized sum. Okay, there is a formula that is L minus 1. L is the pixel values or number of pixel. So you can get 0 to 6, that means 7 pixels. So 7 minus 1, that is 6. Okay, 6 into your cumulative sum will give you a normalized value, and you have to just approximate to get the new pixel value. Okay, so very important concept, histogram equalization. Just go through this question. And then you have this z value, again important. Z value, this is the formula, very simple formula. So you can convert your x value to z value, and actually you would have been given the z values only. Okay, that is z value, that like this. Okay, this as it should be given to you. Okay, and you have to calculate this. So to calculate this, you have to just know how to convert your x to z. Okay, if you can convert your x to z, you can easily calculate all those things. Okay, so this is regarding question 2. Then question third, this is related to Bayes theorem. So Bayes theorem, it is very important. Okay, this is actually the Bayes theorem. Okay, so please go through this, what is a Bayes theorem and how to get this. Okay, so Bayes theorem, one of the most important concept. Okay, you can get your questions all over. Okay, Bayes theorem, so please go through this. Okay, so that is Bayes theorem. This is related to your, I think, Privet or Sobel operator. Sobel operator. Okay, so again, Sobel operator is there, another operator known as Privet operator. Please go through both this operator. You have to just remember this thing. Okay, what are the different gx and gy value for both this. This would be given to you, and you can just do the element wise multiplication to get the uh, get the get the total answer. Okay, after applying Privet operator or the Sobel operator. So again, go through this. And then this is again very important question, very simple question, but can be confusing whenever these things are given. Okay, what will be the range value of x-axis? So 3 bit means 2 to the power 3. Okay, 2 to the power 3 means actually 1 to 8, right? 2 to the power 3 means 8. But don't confuse, in image processing we start our value from 0. So 0 to 7 will be your answer. Okay, so option A will be your answer. So 2 to the power 3, that is 0 to 7, not 1 to 7 or 1 to 8, but 0 to 7. Okay, so again, very simple question, but can be confusing sometimes. So that is our image that we take, that is a 8-bit operator. Okay, that is why we do our color values from 0 to 255. Okay, 256, that is 0 to 255. Okay, so that is related to your related to this. Okay, what will be the range of value, that is what is the range of color values or any type of values. Okay, so this is our normal image. We do the 8-bit operator, we take the 8-bit operator or 1 byte image, so that is why 2 to the power 8, so that is why our value range from 0 to 255. And we have this, if we have this 3 channels, so that is you will get one value for R, one value for G, one value for V. Okay, so that is our normal image. And then this Privet operator, same thing. Sobel operator, you know, Privet operator same, but you have to just remember what is this gx and gy for this Privet operator. So this is question number 6. Question number 7, it is very important, that is Fourier transform, image transform. This is the most important concept, that is Fourier transform. Just go through it, what is the Fourier transform and how to calculate the value. If you are given xt, how to calculate the transform, that is xj omega. Okay, so you can just check how to calculate it and you can just calculate the answer. Okay, so this is the total formula for how to calculate from your normal signal to your Fourier transform signal. Okay, this is how we calculate it. Just remember this formula and you can get the answer. Okay, so it's better to remember this, or if you know the specialized case, then you can remember this, but better to remember this formula. If you just remember this formula, you can solve any question. Okay, so just remember this. Then question number 8, this is very important. Like uh, homogeneous transformation, the last value is nothing but your scale value. Okay, so from homogeneous transformation we have to homogeneous or this projective space we have to convert into a real space. Okay, so that was or very simplified, that what exact which can be a value for your projective which can be a value in your projective space. Okay, so that you have to calculate for this real point 1 comma 3. Okay, so if just divide all the scale values, the last value is nothing but the scale value, so divide this 3 by 3 comma 6, that will be 1 comma 2, so no, 6 by 6, that is 1, 6 by 18 is 3. Okay, so option B will be your correct answer. Okay, because in homogeneous or projective space, the third dimension or the last dimension, if we have a 3D value, then we will have 4 dimensions. So the last dimension is nothing but the scaling value. So just divide the scaling value with your xy or xyz value to get the points in your real space. Okay, so just do this. So option B will be your answer. And this 9, 10, yeah, given the you have this H matrix and you have to solve this. So find the transformation of the line this. Okay, so line is this, so you have this formula. This is the formula how you can convert your line from one from one projective space to another projective space. Just focus on this formula. Similarly, there will be a formula for point also. Okay, and this is the formula for line. So just do this. H you have been given, you have to just find the H inverse and then you have to multiply with the line equation of the line given, and you can get the answer. Okay, so this is the important formula. Similarly, there should be a formula for point also, point transformation. So you just see this. And then question number 10, find the transformation of the point. Yeah, this is that question that I have told you. So you have this H, you have this P, then definitely you do the H dot P and you can get the answer. Okay, so this is the formula for your point transformation and this is the formula for your line transformation. So just remember these two formulas. And then question number 11, compute the line passing through point 3 comma 2 and 6 comma 0. Okay, very easy. How you will do, just first convert this into homogeneous space. After converting this to homogeneous space, you have to just do the cross product, nothing but the cross product. Just do this P1 cross P2 and you will get the answer. So again you have two line and you have to get a point of intersection. So you have this 3 coordinates and this 3 coordinates of line. What you do, just do the cross product of L cross M. Okay, so L cross M you can do and you can get the Euclidean, find the Euclidean angle. Okay, so here angle has been asked. Okay, not the point, but angle has been asked. So to get the angle, this is the formula. Okay, and for this you have to just remember this dual absolute conic matrix equation. If you know this, you have this line formulas, you can easily calculate this angle. Okay, cos theta you can calculate. First you have to calculate cos theta and after that you have to do cos inverse theta. Okay, to get the angle between this two lines. Okay, so that I have told you that this angle formula is very important, that one question would definitely can come. So that is why this is the thing. Okay, so please remember this formula, and from this you just have to remember this term, that is C infinity star. Okay, that is dual absolute conic matrix. Okay, so please remember this two formula, very important to get the Euclidean angle between the two lines. And then you have this given the circle, this which of the following represents circle of a conic. So for this there is a formula to have the circle of a conic. So for before that you have to calculate what is the equation of the circle. Okay, so equation of the circle, everyone know, x minus a square plus y minus b square equals to radius square. Okay, so radius is given, that is 5, so that is why radius square is 25. X minus this, so x plus 3, that will be there, and y minus this, so y minus 2 whole square will be there, and by that you can get the equation of a circle. Once you got the equation of the circle, just compare with this, that is the standard equation of the circle, and you get all the values a, b, c, d, e, f. Once you got a, b, c, d, e, f, just put it and you will get the conic matrix. Okay, so this is question number 13. Question number 14, consider a projection matrix. This evaluate the camera center. So camera center, it is very easy. This projective camera matrix can be written like this. Okay, so first we can just divide this, so we can write m and we can write p4. Okay, and our answer will be nothing but this. Okay, minus m inverse p4 and comma 1, because this, whatever this will come in non-homogeneous space. Okay, to keep it in homogeneous space we have to include 1. Okay, so this is how you calculate the camera center from the homogeneous coordinate. Okay, so this is the thing. If you have this principal point located at 3, 4 and this coordinate system of the image plane, what would be the image coordinate in the world point 1 to 5 using a pinhole camera with focal length f equals to 0.5. Okay, so for this you have to calculate x by this and y by this. Okay, so x is nothing but x will be given by this world point, capital X, capital Y, capital Z is world point, that is the real point. Okay, and the image point will be given by small x and small y. Okay, so if you have this, you can easily calculate the x and y, that is the image point, and f also given, and px, py is also given, that is principal point is also given. So you can easily get the image point from your world point, focal length and your principal points. Okay, so this formula always keep in mind, this is also very important. And then projective camera matrix, compute the plane. Yeah, so HT, I think HTL is the formula. Yeah, PTL is the formula. Sorry, not H, it is a projective camera, so PTL. Okay, so PTL is nothing but transpose of this P matrix or the projective camera matrix into just multiply the line and you can get the equation of the plane. Okay, so pi equals to PTL. So very simple formula, just keep in mind and you can get your equation of the plane. Okay, so very simple, it is just a matrix multiplication. And then consider a stereo imaging setup, this with left calibration matrix this K and right calibration K dash. K means whenever we have dash we are referring to right, whenever we don't have dash we are referring to the left camera. Okay, and right camera has this R matrix, that is the rotation matrix. Based on the given parameters, solve the 17, 18, 19. Okay, so find the homography matrix. So homography matrix, how do we calculate? We calculate homography matrix by this formula. Okay, we have K dash, we have K, we have K, we have we have K dash and we have K, and we also have this R matrix or right camera rotation matrix. Okay, so from this we can easily calculate the homography matrix by this formula. So again, just remember this formula, very important formula. So this is regarding question number 17. Question number 18, given the translation vector t, compute the right epipole. So right epipole, how you can calculate? So actually this is the formula of epipole, E dash equals to P dash C. Okay, so for that you have to know the camera center. So camera center, here the left camera center is nothing but that 0, 0, 0, 1. Okay, because that is how we write the projection matrix of the left camera. Okay, so left camera center we already know, and from this we can easily calculate this this thing E dash. Okay, so E dash K dash R T, that is K dash T only. Okay, so just find the K dash T and you can get your this right epipole. Okay, so that you can get right epipole. From right epipole you can get from this left camera center. Okay, so very important thing to know, to get the right epipole you have to get from your left camera center, so that is important. And P dash is nothing but the projective camera of the right camera only. So from this you can easily calculate this. Okay, So that is how you can calculate the right epicode. And then compute the fundamental matrix. So fundamental matrix is given by this. Okay, so this you have to convert. I have told you how to convert e to simple e dash to your e dash x. Okay, so e dash x you have to first convert your e dash to e dash x. Okay, so just you can refer to my previous videos. So you can, I have told you how to compute e dash x. Okay, once you compute e dash x, you have to multiply with this h. Okay, so just multiply with this h and you can get the answer. Okay, e dash x into h. Okay, so this is how you calculate h. We have actually already computed, so don't get confused. H we have computed in this step. Okay, so same question has been carried out, so that is why e dash x. Just e dash also we have calculated in this. Okay, so don't confuse how we got e dash. E dash also we have computed, just we have to transform our e dash to e dash x. Okay, once we transform e dash to e dash x, is simple multiplication. Okay, so again this is easy. Just remember all those formula. Okay, this is the formula of f, this is the formula how we calculate e dash, and this is how we calculate the h. Okay, so please remember all this formula. If you remember all this formula, you are good to go. Okay, so this is regarding 18, 19, and this is the new question, that is 20. So consider a stereo geometry setup with two cameras p and p dash. If the image coordinate of a 3D point are 10, 3, 15, 3 in left and right cameras, compute the depth coordinate. So again, this is the most important question related to stereo geometry. This very easy question. Just do this. Just put this formula and you can get the answer. X dash is what? 15. Okay, x dash is the right. Okay, so that is 15. X is what? X is 10. So 15 minus 3 will be in the denominator. KTX is nothing but your KTX is nothing but your this thing. Okay, KTX is nothing but this value, that is 5. So just 5 by 10, 5 by 15 minus 10, that will be equal to 1. So 1 is the depth. Very simple question, but keep this in mind. And this is one of the most important question related to your stereo geometry. And then we have this formula for essential matrix. If you are given k dash and f and k, you can easily find your essential matrix by this formula. So again, a direct formula question, so you can just look into this. And then this is actually important, that is parameter related to your f. Okay, so f or the fundamental matrix in parametric form. So please go through this, how to write your fundamental matrix in your parametric form. So here how you can see, how you can they will give you the parameters and they will say that you have to write your fundamental matrix in your parameter, in your real form. Okay, parameters they will give, but you have to write your fundamental matrix full. So for that, you please refer to your fundamental matrix in parametric form. Okay, it is very simple, so you can just go through it. So just you have to remember this. If you just remember this, you can just put the value. All this are given. Okay, no need to worry about this. All this are given. Just put everything to this and you will get the answer. Okay, again a simple question, but again you have to remember this. Okay, so this is related to question number 22. Now question number 23. Consider the matrix representing 4 sample data points, 1, 2, 2, 1, 3, 2, 2, 3. Okay, covariance matrix. So yeah, covariance matrix, again a very important question. So please go through this, how we calculate covariance matrix. To calculate the covariance matrix, we have to calculate this, that is mean of this, then we have to center the data. Once we center the data, then we have to apply this formula. Okay, 1 by n. N is nothing but the total number of points. Okay, so total number of, I think 4 samples are there, so 1 by 4. Okay, and then you have to do the XTC and XC. Just find the XC first. XC is nothing but x minus mu. Okay, once you find the x minus mu, so you can get the XC. Okay, so first you have to find the mu value, that is mean value. Then you how to center the data, your matrix minus the mean value. How you, by this you can center the data. Once you center the data, you got this XC, and XC transpose is nothing but the transfer of the XC matrix, and then 1 by n. By this you can compute your covariance matrix. Again very important question, so please go through this. And then question number 24, given two features, this LP normalization between f and g. So there is a formula for LP normalization. This is the formula. You put the value of p equals to 3 given here. So put the value p equals to 3, and if you put the value p equals to 3, you can easily compute by this formula to get the LP normalization. Okay, f and g are already given, so just do the fi minus gi. I means nothing but the index value, like f1 minus g1 is 3 minus 7. Okay, like that. 3 minus 7, that is minus 4. Okay, minus 4 cube, because p is there, so minus 4 cube. Similarly 2 minus 2, like this. Okay, so again a very easy question, but again important question. So that is LP normalization, but there is L1 and L2 normalization also. For L1 and L2 normalization, nothing you have to do, you have to just put p equals to 1 or 2 in this formula. By that you can also compute L1 and L2 normalization also. So again important question. Find the eigenvalue of the matrix. So eigenvalue, again very simple question, but very effective question, I would say, to compute the eigenvalue. So you all know A minus lambda I mod equal to 0. From that you can get the mod means determinant. Okay, A minus lambda I mod equals to 0. From that you can get the lambda values. Okay, 2 cross 2 matrix means you will get 2 eigenvalues, and similarly 2 cross 2 matrix means you will get 2 eigenvectors also. Okay, so this is very easy question but very effective question, so please go through this. And then question number 26, f and g values are there. Compute normalized cross correlation and cosine similarity. Cosine similarity is very important. So this is the formula of cosine similarity. Very easy formula. F dot g you have to do divided by mod of f and mod of g. So very easy formula but important, and this is how you compute the compute this thing, that is normalized cross correlation. Okay, so this is the formula, covariance of f g and divided by sigma f sigma. This is the formula for covariance of f and g, and this is how you compute the sigma f sigma g. Okay, actually to compute this you have 1 by n here, and you will have 1 by root n and 1 by root n, but 1 by n and 1 by root n into 1 by root n will be 1 by n, so n will get cancelled out. So this is the simplified formula. Okay, but if you just have to find this covariance or fg, you have to put 1 by n here, and you have to, if you calculate sigma f, then put 1 by n within the root, and 1 by n also within the root over here to compute the sigma g. Okay, so by this you can get the Pearson correlation coefficient or normalized cross correlation value. Okay, so again important formula, just you have to memorize this formulas and you are good to go with the question. Then question number 26, again KL divergence. There is a formula related to KL divergence. Just put the values and you will get the answer. Okay, ln, so this ln, so natural log. Okay, natural log, it is very easy. So just put the natural log here, and pi is nothing but 0.2, qi is nothing but 0.4 for first. Okay, and then 0.4 and 0.35, and then 0.15 and 0.05 and so on. Okay, that is P3, and similarly P4, P4Q4 and P5Q5. Okay, every values is given. Just put in this formula and you can get the answer. Okay? Very important, very easy question, but again you have to memorize this formula for KL cross KL divergence. Okay, so please go through this. Very easy question, but you have to just memorize the formula. And then yeah, this is very important, that is to find the least square. So to find the least square or the total least square, so you have this formula. Okay, just go through the formula how to get this, and you will get the answer. Okay, so this is how you calculate this. So you form two equation. From this two equation you just you have this two equation that will be formed, and from this two equation you can easily get the value of a and b by solving this two equation. Two variable you can easily solve to get the value of a and b. Once you got the a and b, this is your line equation, y equals to ax plus b. Okay, so but to form this equation, these are the formula to form this equation. Okay, so for that you have to calculate the sigma x, sigma y, sigma x square and sigma xy, that you have to calculate. Once you calculate all this value, just put here, you will get two equation. You solve this two equation and get the value of a and b, and then put the value in this to get your to get the equation of the line. So that is least square method for line fitting. Okay, so this is question number 28. Question number 29, it is related to color. Okay, This is RGB values are given, you have to calculate in CMY space. So there should be a formula for CMY, that is this, CM and Y, that is nothing but 255 minus RGB. So you can easily put, and this is the answer. Question number 30, again you have been, transformation matrix. So this is the transformation matrix, and to get your values in your CIE chromaticity, this is the formula. So you have already RGB values, you have this matrix, transformation matrix, just multiply this and you can get your values in your XYZ CIE XYZ value. But to get the chromaticity, you have to each value you have to divide by X plus Y plus Z. Okay, so small x you can find by capital X by plus by X plus Y plus Z, and small y you can find by capital Y by capital X plus Y plus Z. Okay, this is question number 30. Question number 31 and 32, it is related to CFA. So please go through CFA. It is one of the important concept, and also it can confuse you a bit. Okay, so please go through this CFA problems. Okay, so interpolate by averaging red and blue to find G8. So G8 is very easy. G8 is nothing, you just get the B8. Okay, interpolation is why we are doing interpolation, because there is some missing values. So you can easily see G8 is missing, but G's are surrounding it. Okay, so easily we can find out G8 will be given by G3 plus G7 plus G13 plus G19 divided by 4. Okay, so very easy, just every value we have, just we divide by 4 and we can get the G8. But this can be a bit tricky, that is B12. To get the B12, what we have to do, we have to get the red. Okay, we have to see the red value, B12 is not there, but have to focus on R12. Okay, once you focus R12, from R12 you have to calculate G12, and from G12 you have to calculate this. Okay, so this is the total formula. So G12, first you calculate G12, and then the B6 by G6, B8 by G8, B16 by G16 and B18 by G18. So first you calculate all this G12, G6, G8, G16 and G18. Once you calculate all this, you put here and you will get the B12. So please go through this. It can be a bit confusing to you. So please go through this question. Okay, CFA question, I would recommend at least please go through this question. Okay, that is regarding the CFA questions. Okay, then you have this compute the Gaussian curvature K. So very easy, compute the Gaussian curvature, how you can compute. So first you have to write the matrix like this, and you have to K to get the formula of K. This is the formula of K, that is determinant of second fundamental matrix by determinant of first fundamental matrix. Okay, so this is the first fundamental matrix, just calculate the determinant of it, and this is the second fundamental matrix, you calculate the determinant of it, you put the value of this and you can get the K value. Okay, so that is how you can do it. Otherwise what you can do, there are other thing, what you can do is to form a characteristics equation. Okay, once you form the characteristics equation, you have two things, one is trace and one is determinant. Okay, so determinant will give you the I think you have two things, right? Gaussian curvature and mean curvature. So determinant will give you the Gaussian curvature, determinant will give you the Gaussian curvature. Okay, and mean curvature is nothing but your trace by 2 will give you the mean curvature. Okay, so either you can go this way or you can simply go this way. Okay, so if you go by this way, you can calculate both, that is mean curvature also and Gaussian curvature also. Okay, so it is your thing how you will calculate. If you have to calculate just one thing, that is either Gaussian curvature or mean curvature, then go through short method, otherwise please go through this long method. So that is regarding 33. 34 question. So you have to, what you have to find, compute the first fundamental matrix from the coefficient t equals to 2, that you have to calculate. So first fundamental matrix, how you calculate, you just form E, F and G, and nothing you have to do. Once you have E, F and G, your first fundamental, okay, so just E, F, G value is already asked. If fundamental matrix has been formed like this, then you have to form fundamental matrix like this, E, F and F, G. Okay, E, F, F, G. So once you got EFFG, you can easily form. Otherwise, if just EFG has been asked, just put the formula E this, F this, and G this, and you can get the answer. Okay, so again it is very simple, so just go through it is very simple. Okay, so this is regarding the question number 34. Question number 35, so EFG is given and you have to calculate the mean curvature. So mean curvature, again mean curvature you can either go by this method, that is the simple method, or you can go by this method, that is the total method. Okay, so just see whatever you feel easy. So this is the formula for mean curvature. So you can just take this formula, you can put all the value E, F, G as well as small e, small f and small g, just put all those value and you can get the answer of what is the mean curvature. Or otherwise the same thing, you just form this matrix, first inverse, you calculate the a trace of it to get the mean curvature. If you just make this matrix, then what will happen is if you just from this matrix, if you just calculate the this characteristic equation from this matrix, then you can get both your mean curvature as well as Gaussian curvature. Okay? So that is how also you can do. Otherwise, shortcut, there is a formula for it, just put all those value in this formula and you can get the answer. So that is regarding 35. 36, all this I have discussed you, so also we don't have much time left with us. So this is related to your KNN. KNN is K nearest neighbor. So K nearest neighbor, there is a method for it to calculate the K nearest neighbor. We have to check what is the first three nearest neighbor to it, and the first three nearest neighbor, what class actually it is given. Okay, so you can see the first nearest neighbor, it is giving C2 class, second nearest neighbor C1 class, third nearest neighbor also C1 class. So C1 class dominates, so we will say the given value is nothing but your C1 class. Okay, so that is how we solve the question of your K nearest neighbor. Okay, so that is question number 36. This is regarding to your neural network. So question number 37 and 38, very easy. So very easy to calculate the output, so nothing you have to do, it is very easy. So inputs are there, okay, and some weights are associated with this, so just multiply the inputs to the weight and add the biases. Okay, if you do this, you can get to the inner half of this part. Okay, inner half, every neuron has two halves. Okay, one is the inner half, one is the outer half. So if you do this, that is W into X plus B, that is weight into the input plus the biases, you can get the inner half. How you can get the outer half? Outer half, it is very easy, you just have to give the activation function. Here activation function ReLU has been given, so just put the activation function and you can get the outer half. Once you get the outer half, this outer half will becoming the input for this very calculation. Okay, so again you have to do the same thing and get to the output. Okay, so I have discussed in detail in my neural network class, so you can just see this. Okay, so this is related to neural networks calculation. And then consider this. So yeah, so number of dimensions, consider a multi-layer which takes a 10D feature. So 10 inputs are there and 2 outputs are there. The network has one hidden layer with 15 number of the neurons. Okay, please note that the input vector, first hidden layer. Okay, what is the dimension of the parametric space? So dimension of parametric space, it is very easy, that is 10 into 15, that is 150, and 15 into 2, that is 30, that is 180. Okay, but 10 into 15, first 15 biases and last 2 biases. Okay, so by this you can easily calculate the total number of parameter. Okay, so that is what I have told you, that is 180, that is 150. Okay, 150 plus 30, 150 plus 30, and that is weights. Okay, 150 plus 30, that is 150 plus 30, that is weights, and then 15 plus 2, that is biases. Just add all this and you can get the answer, that is 197. Okay, very easy, because first you have this 10 inputs and then you have this 15 outputs, so all will be multiplied. So 10 into 15 will give you 150, and then you have this 2 outputs. Okay, so 15 into 2, that is 30. So by this, that is 180. And then why 15 plus 2? Because here as there 15 neurons are there, that is why 15 biases, here 2 neurons are there, that is why 2 biases. So total it will give you 197. Okay, 180 plus 17, that is 197 will be your answer. Okay, so that is how you have to do it. Then question number 40, this is again KNN, so you can just check. I have told you how to do the KNN thing. You have to check the nearest neighbor and you have to vote for it. Okay, so nearest neighbor, which vote is like here the 3 nearest neighbor we have to choose, because KNN k equals to 3. Okay, 3 nearest neighbor we have to choose, and 2 nearest neighbor is giving us good value, so our answer will be nothing but good. Okay, so that is how you have to solve this. And then question number 41, compute the covariance matrix. I have already told you how to compute the covariance matrix. Okay, so just go through it, and same thing. Okay, first you have to center the data, and then you have to do the center into this centered matrix into this transpose of the centered matrix divided by 1 by number of data points. Okay, so number of, not data points, number of samples. Okay, so by this you can easily compute the covariance matrix. So please go through this again, simple formula, simple calculation, so it is very easy. Okay, question number 41, and then PCA. Okay, PCA again, the diagonal will give you the eigen, sum of the diagonal will give you the trace, that will give you the total variance. So just do the sum of the diagonal, and by this you can get the total variance. Okay, so total variance is coming 3.3334. Okay, so option B will be nearest answer. Okay, question number 42, option B is your answer. So again, very simple question. So what exactly you have to do? You just have to take the matrix. Actually, you have to find the eigenvalue. You have to do the sum of the eigenvalue to get the total variance. But as you know that the sum of the eigenvalue is equal to sum of the diagonal of the matrix. Okay, so that is why you can just do the sum of the diagonal elements to get the sum of the eigenvalue of the matrix. That is how you calculate the total variance in the PCA. And then SW and SB, there are formulas, so you have already know what are the formulas to get the SW and SB. S is scatter within, okay, and SB is scatter in between. Okay, so scatter in between, this is the formula. Scatter between, this is the formula. Scatter within, this is the formula. Okay, sigma 1 plus sigma 2, and sigma, how we go, 1 by 4 S1 plus S2. S, how we get, this is how we got the scatter matrix. So again, please go through these formulas, very important, related to your Fisher's LD. Okay, so again a very important question, please go through it. Again, very much chances are there for this type of question to come. 44, this is nothing but OMP problem, so please go through this, how we solve the OMP problem or the orthogonal matching pursuit problem, and just check my previous lectures and you can just see how I have calculated this. Question number 45, it is related to up convolution. Okay, up convolution, it is very easy. So I have told you, you have to just do this formula, keep this formula in mind. You have to find out what are the xij and what are the hpi q minus j. Just refer to my previous class, and I have discussed this in detail. Okay, so everything I have discussed in detail in my previous class only, that is class 12. And softmax prediction, again a simple formula for this softmax prediction. Just memorize this and you will get the answer. Okay, just put y1, y2, y3, y4, p1, p2, p3, p4, everything is given. This is the y and this is the p. Okay, just put in the formula and you will get the answers. Okay, very simple, just you have to keep this formula in mind. And then 47, dimension of this. So again, dimension, there is a formula for calculating the dimension after the convolution filter. Okay, convolution filter, or whatever you would tell, convolution filter. Okay, so this is the width output and this is the height output. Okay, and this is the d output. Every thing has been given. Again, this things has been discussed in my previous class in detail only, so I am not discussing this. The number of parameter, again this is the simple formula. Please refer to my previous class, everything I have discussed, so again I am not discussing. Assume the convolution layer this. Yeah, if you have pooling layer, then your number of parameter will be 0. Okay, so this is type of conceptual question. So if you just see a pooling layer, then after pooling layer the number of parameter will be 0 or no learnable parameter are there. So again this is a simple question, and at last this is related to the inference time. So this is the inference time of your faster RCNN, okay, faster RCNN or fast RCNN. If you have RCNN, then your formula is a slight different, okay. Then you have to multiply number of proposal with this convolution time on. So, and this also I have discussed in the previous class. So again you can please refer to my previous classes for all this. And with this I am ending the session. So I wish you all the best, all the very best and success for your exam as well as for the future, okay. So by this I am ending the
Thank
session.
you, sir. Thank you so much.
Yeah,
Thank you.
so
Thank you so much, sir.
yeah, thank you to all of you
Best
also.
wishes for your future also, sir.
Yeah, sure, sure.
Best wishes for your future.
Yeah. Thank you very much, and all of you also. I wish you all the best for your exam
Thank you,
as well
sir.
as future. And those, thank you. So those who are not giving exam also, my suggestion is, I have prepared all the slides as well as codes in detail. So please download all this, okay? So it will remain in that folder only, but you never know. I might remove after 1 year or something. So my suggestion is, please download everything, okay. That will be nothing like 200 MB or 100 MB like this. So please download that, okay. Download the entire folder, okay. So that is my suggestion. That will be useful for future also, okay. So this is the thing. And yeah, and regarding myself, I have already told many things about myself, but still I want to tell that yeah, so this is my official site, okay, official site or Google site. So you can just check about myself. You can just go to contact us, and these are all my social media link, LinkedIn, and etc. So you can directly contact with me. I am a PhD research scholar from IIT Kharagpur, and I am also researching on computer vision and robotics related to agriculture. So you can contact me for any details. So these are all my social media link, LinkedIn, and anything Google Scholar also you can check. Google Scholar also you can check for any my works and anything papers etc. So that also you can check. So that is regarding myself, okay. So please check if you are interested to be in contact with me after the finish of this course. So that is regarding myself. So by this I am ending the session, okay. So thank you all of you, and we might meet sometimes in the future because a small world, you never know. So that is regarding me. So again I wish you all the best for your exams, and also those who will not give the exam. So no problem. I hope you have learned something from this course, and I have at least tried to given you some concepts and also some ideas how to solve the questions. So by this I am ending the session for the entire course, okay, from my side. I think one
Thank
T
you, sir. Thank you so much.
welcome. So one TA I think is left with the course, so he will also I think finish within this week. So that will be end of this course, okay. So bye everyone.